Start. Welcome back guys. Now in this video, let's discuss about the hypoxia. There are 4 different types of hypoxia. Okay, here are the 4 different types of hypoxia. That's a hypoxic hypoxia, anemic hypoxia, circulatory hypoxia, also called as the stagnant hypoxia, and histotoxic hypoxia, also called as the cytotoxic hypoxia. These are the 4 different types of hypoxia, guys. Now let's see one by one in detail. What is hypoxic hypoxia means? For example, imagine you are living in a high altitudes. Okay, you are living in high altitude. If you are living in high altitude, first of all, the amount of oxygen which is available in that high altitude region, okay, on the top of the hill, the amount of oxygen that is available is very, very less. So if the oxygen is not available, then how come you will get the oxygen? So there is problem outside. Okay, oxygen is not available, so you are not getting the oxygen, your tissues are not able to get the oxygen. So there is hypoxia outside, so that is causing hypoxia to your tissues. So that is hypoxic hypoxia, where the partial pressure of oxygen is very, very less. Okay, or oxygen is there, sir, outside oxygen is there, but you couldn't able to get it, maybe because of some obstructive lung disease like COPD, asthma, pneumonia, okay, or pulmonary fibrosis, some reason, there is some lung pathology where you are unable to get the oxygen, where you are unable to take the oxygen to your blood. So automatically if you are not able to take the oxygen because of some lung pathology, the partial pressure of oxygen in your blood is going to be decreased. So finally the point is, in hypoxic hypoxia, the partial pressure of oxygen in your blood is going to decrease. Maybe problem outside like high altitudes, or maybe problem within your lung like pulmonary fibrosis, obstructive lung disease like asthma, COPD, okay, and even right to left shunt. This is also very, very important. Right to left shunt, where a deoxygenated blood, see, deoxygenated blood is mixing with the oxygenated blood. When you mix that deoxygenated blood with the oxygenated blood, what will happen? The partial pressure of oxygen will automatically decrease because the venous blood is mixing, right? So in all these conditions, see, all these conditions are very, very important. First one is the high altitudes, COPD, lung diseases like pulmonary fibrosis or right to left shunt. So all these are going to cause the hypoxic hypoxia, where the partial pressure of oxygen is going to decrease. See, decrease oxygen availability in the arterial blood. Oxygen is not available in the arterial blood. What might be the reasons? I have told you. Next, anemic hypoxia. Anemic hypoxia means oxygen is there. There is no problem with the oxygen now. Outside oxygen is there, your lungs are also absolutely okay, but hemoglobin is not there. The carrier molecule, the problem is with the carrier. Partial pressure of oxygen here is going to be normal. Why the partial pressure of oxygen is going to be normal? Because you are getting the oxygen, and the 3% of the oxygen, I have told you, the 3% of the oxygen is going to be dissolved in the plasma, so the partial pressure is going to be absolutely normal. The partial pressure of oxygen is going to be absolutely normal. Let's say the partial pressure of oxygen in the arterial blood is 100. But where is the problem? The problem is with the oxyhemoglobin, not the dissolved oxygen. The problem is with the oxyhemoglobin. Now hemoglobin is not there. In this condition, the problem is with the hemoglobin. Hemoglobin problems. Maybe hemoglobin is not available, or the qualitative problem of the hemoglobin, either a quantitative problem or a qualitative problem. For example, let's say, see here, there is anemia. In anemia, what is the problem? In anemia, the problem is less amount of hemoglobin. If there is less amount of hemoglobin, there is going to be less oxygen carrying capacity. More the hemoglobin, more oxygen will carry to the tissues. Less the hemoglobin, less oxygen is going to the tissues. Okay? Or carbon monoxide poisoning or methemoglobinemia. Look, in these 2 conditions, that is the carbon monoxide poisoning and methemoglobinemia, what will happen? See, in carbon monoxide poisoning, now hemoglobin, instead of binding with oxygen, the hemoglobin will love to bind with the carbon monoxide, because the carbon monoxide has more affinity for the hemoglobin. Okay, so in the presence of carbon monoxide, hemoglobin will say, oxygen, I don't want you, I want to bind with the carbon monoxide. Okay, or methemoglobinemia. What is methemoglobinemia? Normally in hemoglobin, what form of iron should be there? Iron should be in Fe2 plus form. But if the Fe2 plus form is converted into Fe3 plus form, such a hemoglobin is called as a methemoglobin, which is a bad hemoglobin. It doesn't bind with oxygen. Normal hemoglobin binds with oxygen, but with a methemoglobin, it's not going to bind with oxygen. So doesn't matter if there is problem with hemoglobin. Oxygen carrying capacity is going to decrease. There is going to be decreased oxygen carrying capacity. Let me tell you. See, in a normal healthy individual, let's say, in a healthy individual, how much hemoglobin will be present? Sir, hemoglobin, let's say 15 grams of hemoglobin is present in every deciliter of the blood. So this is my hemoglobin. Let's say my hemoglobin, my HB value is 15. We all know hemoglobin, one molecule or 1 gram of hemoglobin can carry 1.34 ml of oxygen. 1.34 ml of oxygen. This is normal. So now tell me, what is my oxygen carrying capacity? My oxygen carrying capacity, sir, 15 grams into 1.34. How much? 15 into 1.34, 20 ml of oxygen is present in every deciliter, or you can say 100 ml of blood. So, in every 100 ml of arterial blood, how much oxygen is there in my blood? 20 ml of oxygen is there. That's my oxygen carrying capacity. Let's say a person is suffering with anemia. Okay, let's say a person is suffering with anemia. So, his hemoglobin is not 15 now, it's only 10. So, 10 into 1.34, how much? 10 into 1.34, it's going to be 13.4 ml per deciliter. So, now tell me, more oxygen is going to the tissues or less oxygen is going to the tissues? Less oxygen is going. So, whenever there is problem with hemoglobin, either anemia, it could be anemia or methemoglobinemia or carbon monoxide poisoning, in all these cases the problem is with the hemoglobin. So, the hemoglobin is not carrying the oxygen to the tissues. The problem is here with the hemoglobin carrier problem. So, tell me, in anemic hypoxia, in the name itself it's there, anemia means problem in the blood, the problem is with the hemoglobin. Okay, decreased oxygen carrying capacity. Next, what about the stagnant hypoxia or circulatory hypoxia? See, here the problem is with the circulatory system. Outside oxygen is okay, there is no problem with the oxygen and there is no problem with the hemoglobin, everything is okay. But here the pump failure, the problem is with the pumper, that's a heart related problem. So, the partial pressure of oxygen is also okay, everything is okay. There is decreased blood flow to the tissues. There is some reason blood is not going to the tissues. Okay, there is some reason that blood is not going to the tissues. Maybe the person is having congestive heart failure, the heart is not pumping properly, the blood is not going to the tissues. Simple logic, no? So, the problem is with the heart pump failure, or you can say there is stasis. There is going to be stasis. Okay, what might be the reason? Maybe shock, cardiogenic shock. Okay, cardiogenic shock or neurogenic shock, some reason. Heart failure, heart is not pumping properly, or peripheral vascular disease. Okay, some problem in the blood vessels. Okay, some problem in the blood vessels, maybe thrombus or something is there. Okay, so the blood is not going to the tissues. Okay, there is peripheral vasoconstriction, so the blood is not going to the tissues. So, in all these conditions, either shock, heart failure or peripheral vascular disease, there is going to be stagnant hypoxia. Okay, next, what about histotoxic hypoxia? See, in histotoxic, the name itself is the person is having hypoxia because of some problem in the histo means tissues. See, there is some toxin in the tissue, there is some problem within the tissues. Outside oxygen is there, hemoglobin is okay, the heart is okay, blood is properly going to the tissues, oxygen is properly going to the tissues, but still the tissues are hypoxic because they are not able to use the oxygen, they are not able to take up the oxygen. Okay, so see, impaired cellular utilization of the oxygen, oxygen is going to the cells, oxygen is actually entering into the cells, but the mitochondria is not able to use that oxygen for the production of ATP. Okay, why? In which conditions? Cyanide poisoning, okay, hydrogen sulfide poisoning or cyanide poisoning. So, in these conditions, we all know whenever a person who is taking the cyanide, we know what the cyanide will do. Cyanide is going to inhibit complex number 4 of electron transport chain. Okay, complex number 4 of electron transport chain. We all know it's a complex number 4 which utilizes the oxygen. Okay, which finally in the complex number 4, the electrons are accepted by the oxygen, forming the water molecules. So, what happens if a person is taking the cyanide? The cyanide is going to inhibit the mitochondria. Cyanide is a mitochondrial poison. So, the complex number 4 is specifically affected. So, now the mitochondria cannot use up this oxygen for the production of ATP. So, yes, the problem with the cyanide poisoning is the cellular problem. The cells are unable to use the oxygen. So, these are the 4 different types of hypoxia. Recently asked, the patient who is having a congenital anomaly, congenital heart defect, which type of hypoxia is in? Congenital heart defects can lead to right to left shunt. Shunting can happen, right to left shunt can happen. So, the shunting can lead to hypoxic hypoxia. High altitudes, in high altitudes, hypoxic hypoxia. Heart failure, stagnant hypoxia. Cyanide poisoning, histotoxic hypoxia. In cyanide poisoning, which complex is inhibited? Complex number 4 of electron transport chain is affected. Okay, so these are the 4 important types of hypoxia which I want you to know. After this, let me tell you one important question which was asked. Adequate oxygen delivery occurs in which hypoxia? Which type of hypoxia? Adequate oxygen delivery occurs in which type of hypoxia? Means good amount of oxygen is going to the tissues. Okay, adequate amount of oxygen is going to the tissues, but still the person is suffering with hypoxia. Which type of hypoxia? You all know the answer is histotoxic. Okay, histotoxic hypoxia, also called as a cytotoxic, means cellular problem, cytotoxic hypoxia. So, with this, what we have completed? We have completed the topic of hypoxia. Hope the video is helpful. Thank you.